Hello, Mr. Nennick here. It's about 10:40 on April 29th. And I want to talk about the enhanced risk that's currently a forecast for our area tomorrow and kind of how I see it playing it out. So right now we're looking at the mid-level water vapor imagery for the area. This is the water present in the air as seen by the geostationary GO satellite. The blues and the greens, those are the higher amounts of water, and the yellows and oranges, of course, those are the dry areas. So right off the bat, one thing should really stand out to you, which is the swirl over Arizona. You've got this dry air intruding here, and it's very moist air getting lifted behind it. You can kind of see a spin here. So there's clearly a low pressure system developing here, kind of over southern Utah. And this dry air here is actually what's causing the storm, or maybe kind of the easiest way to understand why the storm is forming. We in meteorology call this a potential vorticity. So we're vecting this thing into the storm, and that is creating the energy in some way that's actually causing this spiral to form. And that spiral has a lot of impacts. You can see right here an ongoing severe weather event across the panhandles with some very large hail. You can see orographic, so mountain-caused rain showers here across the Sierra Madre. You can see obviously some kind of cirrus shield here north of the rotation. You can kind of tell that there's a lot more moisture out in front of this storm as it pushes forward. And of course, as the air wraps around this thing, it's going to wrap moisture up from the Gulf. And I can actually show you that happening. This is a product called the total precipitable water, or TPW. And the brighter colors here just mean more water in the atmosphere. So you can follow the flow off the Gulf of Mexico and up towards us as it goes over the past couple of days. And you can see it's actually built up this reserve of moisture here, kind of across the four corners area of our state, right? Missouri, Kansas, Oklahoma, Arkansas. And if you're really careful and you watch, you can actually see this front come down from kind of Canada and the northern plains. And you can see it fighting its way down and kind of stalling out the progress of this more moist air up. And, there are a few other things to look at here. You can see a front sweeping out the sea over here. You can see the swirl from that low here. You can see more storms in our future out here that are kind of included. All kinds of interesting things going on here. What I really want to point out, though, is there's a lot of moisture in the air across the Central Plains. And that moisture is actually going to quite impact our weather. So here's that driver. This is looking at 500 millibars, which is kind of halfway through the atmosphere. And you can see a closed contour here, a circle. So here's our low and the trough forming that low. And you can see there's some like convergence of flow here. But the flow isn't great. Like you have a northern branch of the jet stream and a southern branch. So you got a split flow around this low. It's not like the whole jet stream is diving south and coming back up. You've got this going on. And really when you come up in the higher jet stream, this storm does exist, but and it's much more clear what's going on. And when you go lower, you almost lose it. And so this isn't the most organized of systems. And if I take a look at this kind of in an easier way to see what's going on, maybe looking at what's called the vorticity, or the amount of spin in the air, I can see the storm pretty clearly. And you can see as I come forward, let's just look at like a time period like 18Z tomorrow. The storm kind of pretty much weakens out. And the only hint that's really here is these little kinks in these iso heights, or these isobars. They're really just about equal heights of the atmosphere. You can approximate them as a pressure gradient. And down at the surface, well, if I do that same thing and I look for the pressure only, well, the low isn't that obvious. You kind of closed off thing here. And actually what's obvious to me looking at it are these kinks rising up through here. These lines that bend back on themselves, right? You see that? So the wind on both sides of those bends, they're different, right? You've got winds from the south up here and winds from the north up here. And it's not really strong, but it looks like this, not really all this stuff out here, is the really notable feature. These kinky isobars that run up and then run down, right? See, there's a kink through here. You see this shape that I'm kind of trying to outline here? You've got something going on here, and then it bends back down across Missouri. Or maybe you could argue it bends kind of through here. And what you're looking at is a stationary front, a stalled front, right? So here's the current fronts. And this whole thing is stalled out for a long, long way. You can see how this frontal position here plays out kind of similarly. Let's go back so it's kind of more accurate to our current time, to where this kink in the isobars is, right? And so this is our feature for tomorrow. And where this front sets up, the areas north of it will have a kind of there's still an appreciable severe weather risk, but certainly a much lower like tornado risk or very large hail risk. And the areas south of it are really where we're going to monitor for the event. So the question we're going to really try to answer today is, where is this thing going to set up? And what's going to happen on both sides of it? So right off the bat, here's an analysis of temperature, and you can really see that boundary clearly. Here it's 64, here it's 70, here it's 59, here it's 66, 58, down to 67, right? You can see that boundary. That's current. And so let's go ahead and just throw this thing forward in time here really fast. And we can see that front really sharpen tomorrow. I mean, here we're looking at like 56 and right here 68, right? Really sharp front. And it kind of becomes a little less clear. And you can actually see there's kind of almost two boundaries to it. There's a secondary little boundary up here, although I don't want to take too much time into that. We're really looking at this shape here. And you can see, for the most part, that strong temperature gradient seems to be setting up to the south of Kansas City. This is now valid about 10 a.m., about, just a little after noon, and you can see this front is really kicking across Oklahoma. And Kansas City is really struggling to warm up. And then, we still have this defined boundary and kind of this, you see this shape with a horizontal line to down. So I would argue what's going on here is you've got your stalled boundary here that's becoming progressive because it's got thunderstorms going on. And you've got a warm front through here, and a really defined warm front over Illinois, which is something to notice. So here we are, and we can kick that thunderstorm forward. This, you can see very cold air here compared to where it was, right? Look at the temperature drop. Here it was 73, and then go forward just 3 hours, and now it's 58. What this is here, this is not just the front. This is rain-cooled air. This is the computer saying, hey, it's going to rain here so much, it's going to cool off the air as it evaporates, and it's actually going to knock that energy down. And when that happens, you get this cold pool of air and very much warmer around it. This wants to surge. It's more dense. So what you're going to get is a line of thunderstorms that forms on the leading edge of this. And they call the Mesoscale Convective Complex, an MCC or an MCS, depending on the scale. And it's going to propagate forward and eat up this energy. So we can tell, just looking at the temperature graph, what the model already thinks is going to happen. We think there's going to be a big line of thunderstorms running through here, right? And this is at 6 p.m. tomorrow, give or take. And that maybe north of this line, we really don't need to be concerned about. And if we just look at Kansas City here, you can see we're right on that edge of really kind of the interesting stuff happening. Okay, so I can take a look at that. And while I'm here, it's probably good to look at the moisture too, because obviously thunderstorms need forcing mechanisms and a lot of things, but ultimately they also need moisture. You can see in that total precipitable water we were seeing that nice, warm, moist air mass across, again, I said the kind of four corners region of our state. And you can see the dew point's already 65, 66 right now. That's quite high, and that's notable. And as I come forward, you can see that moisture pooling really actually even somewhat increases. That's pretty interesting. You can see actually up to even the 70s here, that's really quite humid. Anytime you see 70s in late April, early May, you're really going to take heed of that. You also will notice that Kansas City really struggles to get up above about 58. Now you notice there is some pooled moisture here. And this is something that we need to watch, because this moisture, even though our temperatures are not that much higher, again, this is valid at 0Z tomorrow, and this is as well, right there. Here where our temperature is forecast to be 60 degrees Fahrenheit, and here's dew points forecast to be basically the same thing. So we know that we have a lot of, saturated air, basically. You can see that even gets stronger here across, again, the Illinois region. You can see that, the impact of thunderstorms. So this could provide us a little bit of energy, even though we're north of that boundary. Now we can look at the energy by looking at the CAPE, and if I do that, you can see the surface-based CAPE really does show that same boundary clearly. Again, I want to highlight Illinois here. Maybe you can see where I'm actually going to point. I think there's something that's been missed in the most recent Storm Prediction Center forecasts. But again, you can see there's this thin band of strong instability strong but notable instability along the warm front, as well along here. And we'll come back and look at this in a minute. And if I take a look at that and I compare it to just another model, this model being a slightly higher resolution model, you can really see that moisture and that energy trying to reach us and getting eaten by that big thunderstorm complex, right? It doesn't mean all the energy is gone. You can see this hole here being caused by thunderstorms forming, right? And so it looks like as storms form to the south, some of the instability that we might get in Kansas City is going to be consumed by the storms that form down here. We can quickly get an idea of the storm's motion by just looking at updraft helicity. So you can see that most of the storms are going to be tracking kind of at about a 30-degree angle north of east. And whatever measure this is, which is updraft helicity, is highlighting this area across northern Arkansas as perhaps having a little bit more aggressive thunderstorms. This is a measure of how likely air is to rise and rotate. And so you can see, of course, the warm front has a little area highlighted in this particular model, as well as this larger swath down here. So it's not a great forecast, but it's worth your time to look at this forecast and say, okay, well, actually this area here maybe looks like it's got the best chance for a rotating updraft. So maybe this is the area we'd want to look for tornadoes. It's not that simple, but it's a good starting point. Because I know you're still learning how to do with weather, let's just look at some model radar, because we all understand what radar looks like. So what's going to happen is the storms are going to form as these elevated thunderstorms. So these are not particularly big thunderstorms. They're storms that are forming well above the ground, maybe 3, 4, 5 kilometers in the air. We'll talk about that in a minute. And those will push along north. And you can see this area that we highlight down here, currently forecast to make thunderstorms. And I should point out, this forecast stuff here that's happening, right? This first burst of thunderstorms, this is like 6 in the morning tomorrow, 7 in the morning, 8, 9, 10, 11, 12, right? 13, 1, 2, 3, 4, 5, 6, 7, right? So you've got this storm complex. It's during the day. It's not in the evening like you're normally used to, waiting for the cat to break and all these things. It really is just as this day gets going, these storms form. And so you can see I was talking about these storms to the south robbing our energy, and you can kind of see that happening, right? Here at 15Z at 10 a.m., you can kind of see the storms to our south probably taking some of the energy that would normally make it if it's our way. Now this is the WRF, and different forms of this model will give us different ideas of what's going on. But you can see that story is kind of consistent. Overnight thunderstorms, storms form here kind of through this region, organize into like a bowed MCS structure. Here you can see again that stationary front to the warm front through here. And then those track out. Now this becomes quite a complex of thunderstorms at times, but these two models show basically a miss for Kansas City. If we take a look at the NAM, we get a little more complicated picture. We still see those storms forming. Here we are again looking at the overnight storms to our south, but they kind of fall apart. And in their wake, that leaves new instability, and that lets a kind of different shape thunderstorm form. For one thing, notice that the warm front here is actually not got a whole lot of instability on it right now. It doesn't have a lot of convection forming on it. Very, very interesting. And so I know it doesn't look that different. You're like, it just looks like radar, Mr. Nidek. But actually, that progression versus this progression is pretty different, especially when it comes to those warm front storms. Look at the HRR, which is my favorite model for modeling these kinds of storms. We can see those same convective showers form. Get your complex there, same thing, right around, 8 in the morning, 9 in the morning. Those things come through, and it also shows an opening. But the difference here is that opening is actually long enough that we get a little bit of sunlight, and that actually causes all kinds of popcorny storms. And you can see these storms get quite intense down here. This storm here would be very interesting. This storm here would be very interesting. These storms here would be very interesting. Okay, this is a lot different of a picture than when I come over here and look at this. So I just want to point out that was 20Z. This is 20Z. So look at that picture versus the picture again. They look similar at first glance until you realize they're really telling a different story. And so we do have to figure out what's going to happen. Now, eventually, what's going to happen is to our south, there will organize a major mesoscale convective system. But whether or not that system can organize, here versus here versus here, that does dictate our weather. And so I want to talk about down here, this is big. You can see obviously these individual thunderstorm cells near the end of the day. I can launch a weather balloon through here, and it will load. It'll take it a second. Slow. And you can see down here there is cold air. Yeah, down here there's warm air, excuse me. And this thunderstorm has nothing inhibiting its rising. It rises to like almost 15 kilometers in the air, right? And there's a nice sweeping autograph here. And these two things together, and even though there's a skinny cape through here, which doesn't generally support that severe weather, suggests this area will have rotating updrafts. So this is something here that I would consider a decent tornado sounding. And so I would say, yeah, these storms, if they can stay apart and stay individual cells, especially like this cell, which is all by itself out front, I would say this area over Arkansas would be a good area to look for tornadoes. And here, of course, we've got that same nice little bit of cape. Nothing crazy. A nice sweeping autograph with a little kink here, which generally kind of inhibits tornado formation, but still nothing bad. And, you start saying, okay, there's a decent tornado risk down here. But also over here in Illinois, we've been talking about and kind of alluding to the fact that, hey, there's something over here. So here we're looking right at 5 p.m., but just pull up Illinois here. Well, take a look at this. Lots of instability close to the ground surface where they're forming. Nice, wide, sweeping autograph. The computer's actually saying, hey, this in the past has produced really strong tornadoes. And this is an area that hasn't been highlighted, at least until recently, in the Storm Prediction Center. So I expect at, here in an hour when the new forecast goes out, that this area actually becomes the interesting area for tornadoes tomorrow. I think this is the area, if I could just wave a magic wand, where I would actually chase. Kind of interesting, right? All the focus in the last couple of days has been down here. Don't get me wrong, these are still strong thunderstorms, but these might actually be the ones that produce the prettier tornadoes. Now, it doesn't matter to us, so our question here in Kansas City, what's going to happen here? So let's quickly go through this and kind of look at storms that are the most interesting. We get lots of thunderstorms. Let's choose kind of these little pop-up storms, right? Like this little storm here. What if that were to form up here, right? Again, that's just a boundary position. Let's go ahead and take a look at him. Well, something interesting is happening here. One, our autograph doesn't have the nice sweeping shape. It kind of looks like a roller coaster. So this storm's not as likely to produce a tornado from that. And also look where the thunderstorm starts. It starts up above the ground. It starts at 3 kilometers. So there's no energy coming from the surface. The energy is actually coming off the top of this inversion. And that's pretty common. Actually, as I look at any thunderstorm in our area tomorrow right now, here we chose this thunderstorm. Let's choose, some of these thunderstorms here, the ones that are going to come through a little earlier in the day. Hey, they form above the ground too. And actually, if I come here to kind of peak intensity, and I take a sample south of the warm front here, even here, I'm really only seeing the instability above this warm nose. So these thunderstorms in Kansas City aren't very likely to be getting energy from the surface. If you don't get energy from the surface, you're not going to get the most significant severe weather. So personally, I wouldn't put us above a slight risk in Kansas City, and I would have earlier today. But as the models have come through, it's becoming very clear, at least in the current modeling, the warm front isn't really going to progress beyond about here. So as long as we keep this warm front south of the city, our risk is low. Instead, what I would do is highlight a couple things. I would highlight a conditional tornado threat here and a more significant one over here. I would highlight, of course, the damaging risk threat from that large mesoscale convective complex or system, depending on the size it actually ultimately takes. And, of course, the hail threat, because if I take a look at the thunderstorms as they form in here, let's just look at these here. You'll note there is quite a bit of cold air aloft. So if I look at where it's 0 degrees, everything above here is frozen. So there is a good hail risk in these storms as well. And I'm waving my hand at hail. Hail is way more complicated to forecast than that. So we'll see where it is. But if we go look at the Storm Prediction Center right now, and actually take a look at the storm as it's currently forecast, you can see right now, at least, the area that actually kind of maybe looks the most interesting is being missed. And this looks a little too far north. So again, let's say we can adjust this. We've seen the data, and before this comes out, we might expect the enhanced risk to move a little bit more over here. And we might expect a new tornado risk to be drawn in here. So we'll see if we're right? This is a forecast. This will be issued right now. It's currently 359Z, and it will be forecast no later than 6Z by a couple hours from now. So we will see. In Kansas City, unless that front can get farther north, I expect this whole thing to shift a little bit farther south, and so we ultimately end up looking at a slightly less interesting setup than we were looking at earlier today. Hopefully you can follow that along. I know it's a little bit rambly, but that's how forecast discussions tend to go, and enjoy the day.